Let's continue with these questions. Question 57, we have the question: Pamela factorized the following polynomial, 2x cubed plus 3x squared minus 3x minus 2. She found the result as x plus 2 into x minus 1 into x minus 2. Using remainder and factor theorem, verify whether her result is correct. If incorrect, give the correct result. So for this question, let's take the cubic polynomial as f of x in that notation. So it will be easier to solve the remaining part of the question. So we will say that let the cubic polynomial f of x is equal to this much. Now the polynomial in the question, so a student has already factorized into three factors: x plus 2, x minus 1 and x minus 2, but we are not sure whether the factorization was correct. So we have to use our remainder factor theorem to verify whether the factors are actually correct. So suppose the first factor x plus 2, if I want to verify if x plus 2 is a factor of the cubic polynomial f of x, then we have to think for what value of x is x plus 2 0, and we know that it's for x equal to minus 2. So then x equal to minus 2, if I substitute in the dividend and if that is equal to 0, then I can say x plus 2 is a factor of the dividend. So if I substitute x equal to minus 2, f of minus 2, if I evaluate, substitute x equal to minus 2, I am getting 0. So I can say, okay, x plus 2 is a correct factor of the dividend. In the same way, check for x minus 1. If I substitute x equal to 1, then the divisor is 0. So substitute x equal to 1 in the dividend, and if you evaluate, again you get 0. So x minus 1 is also a correct factor of the given cubic polynomial. But if I look for x minus 2, for x equal to 2, the divisor is 0. So then substitute x equal to 2 in the dividend, and if you evaluate, you get something like 20, which is not equal to 0. So x minus 2 is not a factor of the dividend. So this is the incorrect part in the answer. X minus 2 is the incorrect factor, but two other factors are valid. They are correct. So you have to write a conclusion stating that overall your result is incorrect, as x minus 2 is not a factor of your polynomial. But also mention that x plus 2 and x minus 1 are factors of the polynomial. Now if we have two factors of a polynomial, if I multiply the two factors, the result is also a factor of the polynomial. So if I multiply x plus 2 into x minus 1, I get x square plus x minus 2. So this quadratic polynomial is a factor of my original cubic polynomial. So if I want to find the remaining factor, which is the correct factor, I can just do a long division where I'm dividing. My divisor is x square plus x minus 2 and my dividend is my original polynomial. And if I do the long division, then I get a quotient which is 2x plus 1. So my polynomial, my cubic polynomial, is a product of the divisor and this quotient. So if I write that, then I get all the correct factors. X plus 2 and x minus 1 were anyway correct, and then 2x plus 1 is the third factor. So product of this is actually the correct factorization for my cubic polynomial. Then moving on to the next question, question number 58. We have two matrices given, matrix A and B. Find matrix M if M is equal to half of A minus 2B plus 5I, where I is the identity matrix. Okay, so for this question, this is the value of matrix M. So I have just to substitute matrix A, B and identity matrix. So if I just substitute that, half into matrix A minus 2 into matrix B plus 5 into identity matrix. Because all the other matrices are of order 2 by 2, my identity matrix also has to be of order 2 by 2 in order to add and subtract, right? So identity matrix of order 2 by 2, I will have the diagonal elements, principal diagonal elements 1 and the other elements 0. So 1, 0, 0, 1. This is going to be my identity matrix. Then I have to multiply a scalar with a matrix, a real number with a matrix. So the real number I'm multiplying with each one of the elements in the matrix. So half into minus 6 is minus 3, half into 0 is 0, half into 4 is 2, half into 2 is 1. Okay, then I have minus 2 into this matrix. So this minus 2 into this, I can convert the subtraction to addition, and I can just multiply minus 2 with all the elements inside the matrix. So minus 2 into 1 is minus 2, minus 2 into 0 is 0, minus 2 into 1 is minus 2, minus 2 into 3 is minus 6. And outside the matrix, now I have addition instead of subtraction. Then 5 into 1, 5, 5 into 0, 0, 5 into 0, 0, 5 into 1, 5. Then I have three matrices which I am trying to add. So the result will be the addition of corresponding elements. So first row, first column element, minus 3, minus 2, plus 5. It adds up to 0. Then first row, second column element, 0 plus 0 plus 0 is 0. Then 2 plus minus 2 plus 0 is again 0. Then 1 plus minus 6 plus 5 is also 0. So finally I get a matrix having all the elements 0. That is also known as a null matrix. Okay, moving on to the next question. Question number 59. This is from AP. Write the nth term of an AP consisting of all whole numbers which are divisible by 3 and 7. How many of these are two-digit numbers? Write them and find the sum of the first 10 terms of the AP. So now if I have any whole number which is divisible by 3 and 7, it has to be also divisible by 3 times 7, 3 into 7, which is 21. So we are basically looking at all the multiples of 21. They are going to be divisible by both 3 and 7. Okay, so then the first element, the first number in my matrix is 21. Then the next one is 21 into 2, which is 42. And then 21 into 3, 63. So then 21, 42, 63, this will form an AP where the first term is 21 and the difference between consecutive numbers will also be 21. Then the question was asking us to find the nth term of this AP. So nth term of an AP, notation I can use an or tn, both are the same thing, is a plus n minus 1 into d. A is first term 21, n minus 1, we are taking in general the nth term, so let it be n. Then common difference d is also 21. So if I evaluate that, I get the nth term as 21n. So the first term itself is 21, second term is 21 into 2, third term is 21 into 3, so nth term is 21 into n. So any which way, I get the answer for nth term as 21n. Then the question was asking that how many two-digit numbers will be there in the AP. Now since the numbers are very small, you can even just write down the numbers and you will get that there are 4 numbers which are two-digit. After that, you will have 3-digit numbers. But in general, if I want to solve such a question, I have to assume that let the nth term of the AP is just less than 100. Then I have to find what is that value of n for which the term is going to be less than 100. 100 is a 3-digit number. So if I want to find 2-digit numbers, I have to have the term less than 100. So if I just substitute the value of nth term, 21 and less than 100, n is going to be less than 100 by 21, which is mixed fraction 4, 16 by 21. So n has to be less than 4 something. N is always a natural number. It cannot be a fraction or a decimal. So the largest value of n possible is 4. After that, the fifth term onwards, it's going to be more than 100, which is 3-digit numbers. So I will conclude that there are exactly 4 terms. The first 4 terms of the AP are 2-digit numbers, which are 21, 42, 63, and 84. Okay, and finally they have asked us to find the sum of the first 10 terms of the AP. So that I can use the sum of n terms of an AP formula. This is the formula that you all know. Then substitute the values. N is 10 terms. A value is 21, so 2A is 42. N is 10, n minus 1 is 9. Common difference D is 21. So if you evaluate that, you get the answer as 1155. Then moving on to the next question. This is from sequences. So they are saying write the first 5 terms of the sequence given by root 3 to the power n belongs to natural numbers. So they're asking first, is the sequence an AP or GP? So we have to identify that. So to do that, you can try to write what are the first 5 terms of the series. So because n belongs to natural numbers, so n can be 1, 2, 3, 4, 5 and so on. So then the terms of the AP will be root 3 to the power 1, which is root 3, root 3 to the power 2, which is 3. Root 3 into root 3 is 3. Then root 3 cube is 3 root 3. Root 3 to the power 4 is 9. Root 3 to the power 5 is 9 root 3. So these are the 5 terms of my sequence. And if I check whether they have a common difference or common ratio, the difference between the consecutive terms is not the same, but the ratio of the consecutive terms is same. Therefore, it is a GP. And the reason is the consecutive terms have a common ratio. And the first term of the series is root 3 and the common ratio is also root 3. If I take any two number, for example, if I take 3 root 3 by 3, the ratio is root 3. Okay, then the question said that if the sum of 10 terms of this series is equal to P into 3 plus root 3, find the value of P. So then I will use the sum of n terms of a GP formula, which is a into r to the power n minus 1 whole divided by r minus 1. A and r value both are root 3. So substitute root 3. I am looking at sum of 10 terms, so n value will be 10. So if you substitute those values and simplify a little further, root 3 to the power 10 is same as 3 to the power 10 by 2, or 3 to the power 5. If you calculate, it's 243. Okay, then the sum is equal to P into 3 plus root 3. So then this 3 plus root 3 you can bring to the other side, and 3 plus root 3 will be divided on the other side. So therefore P value is root 3 into 242 whole divided by root 3 minus 1 into 3 plus root 3. So then if I multiply the terms in the denominator, I will see that this plus 3 and minus 3 are getting cancelled. 3 root 3 minus root 3 is 2 root 3. And then root 3 and root 3 can be cancelled from the numerator denominator. 242 by 2, the result is 121. So the P value in the question is 121. Moving ahead to the next question. Next is from coordinate geometry. So the question is about a figure given where they are saying that ABC is a triangle. Write down the coordinates of A, B and C on reflecting through the origin. So if you look very carefully, coordinates are not mentioned, but from the graph, I can try to find out what will be the coordinates. So for point A, it is along the x-axis 4 units, y-axis 5 units. So A is 4, 5. B, it's on the y-axis and 3 units above the origin. So x coordinate is 0, y coordinate is 3. So B is 0, 3. C is on the x-axis at x equal to 3. So x coordinate is 3, but y coordinate is 0. So these are the coordinates of A, B and C. And then you have to reflect A, B and C on the origin and then write the coordinates. So you can write the answer something like this. Suppose you have the point A 4 comma 5. Whenever you reflect in the origin, you know that the x and y coordinates sign will change. So 4 will become minus 4, 5 will become minus 5. So all the 3 points, if you reflect in the origin, these are the coordinates that you will get. Then question was to write down the coordinates of the point or points which remain invariant on reflecting the triangle ABC on the x-axis and y-axis respectively. So I had all the 3 points. So let's say we are reflecting all the 3 vertices of triangle ABC on the x-axis. Then you see that A will come below the x-axis, B will also come below the x-axis. But C is a point on the x-axis. If you reflect it on the x-axis, the image will still be 3, 0 itself. It's the same point. So I will say that when I'm reflecting ABC on the x-axis, point C 3, 0 will remain invariant. In the same way, if I am reflecting the triangle on the y-axis, point B is on the y-axis. So on reflection on the y-axis, B will not change. It will remain the same point. Point A will come over here. Point C will come over here. But B will remain on the y-axis. So for reflection on the y-axis, point B will remain invariant. That's your answer. Let's look at question number 62. This question is from, I think, section midpoint formula and also some knowledge of equation of a line. So we have to determine the ratio in which the line y equal to 2 plus 3x divides the line segment AB joining points A minus 3, 9 and B 4, 2. So it's useful, it's helpful to just draw a rough figure, line segment AB, and a line is dividing the line segment AB into 2 parts, and I want to find the ratio. So you can take, let the ratio of AP is to PB, calling point P as the point of intersection, be K is to 1. Let's say that's the ratio. Then if I find the value of K, I will find what is the ratio. Now, if I apply section formula normally, the x coordinate of point P, let's say x, will be equal to K into 4 plus 1 into minus 3. So 4k minus 3 divided by k plus 1. That's the x coordinate of point P. And the y coordinate of point P will be equal to k into 2 plus 1 into 9. So 2k plus 9 divided by again k plus 1. So this is x coordinate of point P, y coordinate of point P. Now point P is also a point on the line with the equation y equal to 2 plus 3x. So whatever are the coordinates of P, if I substitute those values of x and y in the equation, then it has to be satisfied. So these are the x and y values. If I substitute these x and y values in this equation, the equation will be true. It will be satisfied. So if I plug in the values, I will get an equation with my variable k. Then I will solve it step by step. I will get k is equal to 4 by 3. So the ratio, I had assumed k is to 1. So the ratio will be 4 by 3 is to 1. If I multiply 3 on both the parts, I have 4 is to 3. So 4 is to 3 is the required ratio in which the line segment AB is divided.